Hello, geometry students, and welcome back to another video lesson where we continue to talk about triangle congruence proofs, and triangle parts being congruent through CPCF. Friday, after the quiz, you were asked to begin looking at an introduction to lesson 7-4 on overlapping triangles, and that's where we're going to begin today with our proofs using these overlapping triangles. So the proof, given that angle ARN is congruent to ALG, and that segment RN is congruent to segment GL, we need to prove that segment A to G is congruent to segment A to N. And really, when you have these overlapping triangles like this, where I have a bunch of triangles in this diagram, we really need to start by determining what overlapping triangles are we trying to prove are congruent. Because remember, if we're going to try and prove that parts are congruent, I do have to prove the triangle's congruent first. And so the goal is to really kind of look at, the statement prove. We're trying to prove that AG is congruent to AN. AG and AN. And so if I pull those two out, AG, can't really actually do that. AG, notice I don't want to go all the way over here to N because that would give me this whole big triangle. And so A to G to L is one of my triangles that I need, A to G and L. And then if I'm trying to get AN, which is the other right-hand side, again, I have to go back up here to R to get back to A. So here are those two triangles that we're trying to basically prove that these two triangles are congruent. Once we can prove the triangle's congruent, then we can prove the parts are congruent. So let's take a look at what that looks like. We are given that angle ARN is congruent to ALG. ARN is congruent to ALG. We are given that information. We are also given that RN, which was this side, is congruent to LG, which is this side. We're trying to prove that the two segments are congruent. Now, anytime we have overlapping triangles, there's probably something that they share in common, that they both have in common. In this triangle, they both have this angle A in common. It's the same angle, right? We're pulling it out from the top of this triangle up here. It's the exact same angle. And we can say angle A is congruent to angle A. Anytime we're saying something is congruent to itself, that is the reflexive property, a reflection or a reflexive property. And anytime, again, you have these overlapping triangles, we're probably going to use something like reflexive because something has to be congruent to itself. Now that I have A congruent to A and the two angles here and the sides, we can definitely say those two triangles are congruent. Triangle ALG is congruent. How about I put the congruent sign in there? As ARN. What allows me to say that those two triangles down here are congruent? Angle to an angle to a side. AS. Angle, angle, side. And now that we have the two triangles congruent, we can go one step further to say that those parts are congruent, that AG is congruent to AN. And anytime we have triangles congruent, and then we're going to say that the parts, key being parts, are congruent, CPCF, corresponding parts in congruent figures. So again, we got to say the triangles are congruent first, so then I can say those matching parts are congruent. Let's take a look at example number 2. Same exact triangle that we started with, but we're probably going to work with different triangles here now, okay? we've got Rn congruent to GL. Rn, so that's this segment, congruent to GL, and GT congruent to TN. We want to prove that angle G down here is congruent to angle N down here. So we're trying to figure out, based upon that prove statement, that this angle G is congruent to this angle T. Let me just draw those in red. So this angle G congruent to this angle N, the whole thing. We're also using Rn. So that would be this triangle right here, GRN. All right, there's GRN. And then we also have LG, GL, which is then from G to L to N. So that would be our second triangle. All right, so using pretty much what they're proving and then trying to use the other given, I can see which triangles we have that we're using. And again, those were overlapping. Okay, they share something in common, and we'll get to that here in the proof. So let's walk through what they give us. Rn is congruent to GL, so those two are congruent. And G to T is congruent to T to N, but we don't have those. We don't have those. Well, that's not very nice, Mr. Goodacre. You copied something down wrong. I am going to change this right here. We're going to say that GR is congruent to LN. GR should be congruent to LN. This side should be congruent to this side. So that would be part of our given. GR is congruent to LN. Sorry about that. See, we all make mistakes. Now we just move on. So once we have that set up, notice I've got two sides congruent to two sides. Notice both triangles here have GN and GN, so it has to be congruent to itself. That's the overlapping part that both of these triangles do indeed share. So we're going to say that GN is congruent to itself, which is GN. And what is our justification for that? Again, that's the reflexive property. Anytime something is congruent to itself, that's the reflexive property. Now that we have that, the two triangles, hopefully you can see that those two triangles are indeed congruent. GRN is congruent to NLG. What allows me to say that those two triangles are congruent? Which theorem is that? Side, side, side. And now that we have two triangles congruent, we can say that the parts that they're asking us to prove, angle G is congruent to angle N because the parts are part of C. P, C, F, corresponding parts in congruent figures. So the goal with this lesson is to really understand, how do I pull apart the triangles to then work on naming two triangles that are congruent to each other with one of our four congruence theorems, and then using that to say that the parts are congruent based on CPCF. If you have any questions, please indeed make sure that you reach out. Otherwise, until next time, everyone, stay safe.